chemistry warriors. Welcome back to my channel. My name is PrachiSharma and today is day 7 of the test series. Today's topic is metallurgy. If you're new to this channel and this is the first video you are watching, we have a test series going on for Chemistry ICSE Grade 10th, and every day we pick up one chapter and we discuss the questions from that particular chapter, all those questions which are important, which we have seen coming up in board examinations, and we discuss the answers in detail. The question paper is released one day before on the Telegram channel, and the video is uploaded the very next day. So you get one whole day to work on the question paper on your own and then join the video to understand if all your answers were correct or if you need to improve something. So without wasting any time, let's get started with metallurgy. Alright students, I hope my screen is clearly visible to you. So let's get started with the first question. So metallurgy chapter, very less portion is coming, a lot of part of it is cut out. I have attached a one-shot video of metallurgy in the description box, so you can find that easily if you have not covered the chapter yet. Now when we start with the first question is a basic hoops process. All the information is mostly given in the diagram itself, and if you understand the process, this question is pretty easy. So let's start with the first one. Which of A and B is the cathode and which one is anode? So if you look at B, and if you remember from Hooke's process, so B is always connected to the positive terminal, so B is anode and A is cathode, the graphite rods, that is cathode. Now moving on, the next question is, what is the electrolyte in the tank? So if you see, they have already marked molten fluorides, so that is your electrolyte. So we'll write molten fluorides. Then what material is used for the cathode? So A you marked as cathode, right? So what is the material on it? It's graphite material, so graphite rods. Or if they are asking just the material, just graphite. Now moving on to question B. Now this B is state the property of the metal being utilized in the following. So this is from the last part of the chapter. If you are working from Selina book, so in that book, last page of the chapter is basically a chart that is given to you, which contains alloys, what they are made up of, and the uses. So this is directly from that. They have also mentioned the property of that. So zinc in galvanization. So zinc is used in galvanization because it is resistant to corrosion. So because of its property of being resistant to corrosion. Then aluminium in thermite welding. So we use aluminium because of its reducing nature. Okay. So it's a reducing agent. Then moving on, select the correct answer from the choices A, B, C, D which are given. Brass is an alloy of what? Now this is also from the last page of the book, the same chart that I just mentioned. So brass is made up of copper and zinc. Now moving on to question 3. Now question 3 is again a rephrased question, similar like what we just did in the first part. It is that question, just different setup is made. But you can still understand it clearly if you have learned the process. So let's start. The following is a sketch of an electrolytic cell used in the extraction of aluminium. What is the substance of which electrodes A and B are made? So if you come back here, you can see that A is your graphite. So you'll directly mention that, A in this question is this dark red, the dark black area, this one. So this is made up of what? This is made up of carbon. You can see carbon lining. So you can directly write that substance A is carbon. And B, if you remember from the A diagram, it is graphite. So B is graphite. At which electrode A or B is aluminium formed? So aluminium is formed at A. Okay. So it is formed at A or cathode, whatever you want to write. What are the two aluminium compounds in the electrolyte C? So in electrolyte C, the two compounds that you have is pure alumina and cryolite. So pure alumina and cryolite. Why is it necessary for electrode B to be continuously replaced? So we replace it because it gets oxidized to carbon dioxide and slowly starts getting thinner and thinner. So as the oxidation keeps happening, the rods are, they become very thin. So it's important to keep changing the rod so that your reaction is consistently going on without any breakage in between. So that is the answer for the fourth part. From the list of characteristics given below, select the 5 which are relevant to non-metals and their compounds. So non-metals and their compounds. Let's start with A. A is ductile, so metals are ductile. Non-metals are not ductile. Then conduct electricity? No. Brittle? Yes. So non-metals are brittle. Then acidic oxides? Yes. They form acidic oxides. Then basic oxides? No. Discharged at anode is correct. They are discharged at anode. Then ionic chlorides, yes, they form ionic chlorides, and they also have 5, 6 or 7. No, they don't form ionic chlorides, they form covalent chlorides. And their valencies are 5, 6 or 7. So L. Is there anything else? Basic oxides discharged at anode. Yeah, that's it. Write the 5 letters corresponding to the correct characteristic. So you just have to mention the alphabet. So you'll say C, D, F, I, L. C, D, F, I, L. Okay? Alright students, let's move on to question number 5. So question number 5 says, the following is an extract from Metal in the Service of Man, Alexander and Street, Palestine, 1976. They say, alumina has a very high melting point of over 2000 degrees Celsius so that it cannot readily be liquefied. However, conversion of alumina to aluminium and oxygen by electrolysis can occur when it is dissolved in some other substance. So students, in the exam, they can always give you a paragraph like this, which may or may not have any information. So this one is not really giving us a lot of information. But I always suggest read the whole question, because sometimes you can get a hint or it can help you recall from your memory some important part of the answer. So let's get started with the first part. Which solution is added to react with bauxite as a first step in obtaining pure aluminium oxide? So sodium hydroxide is the first step. Remember from the process, sodium hydroxide is the first step. So the answer is sodium hydroxide. Second is the aluminium oxide for the electrolytic extraction of aluminium is obtained by heating aluminium hydroxide. Write the equation for this reaction. Okay, so if you think of this, aluminium hydroxide is being heated. Okay, so let's start with that. So aluminium hydroxide is Al. OH whole thrice. You are heating it. So what will you get? You'll get aluminium oxide. So that is Al2O3 plus water. Then moving on, the next is name the element which serves both as the anode and the cathode of in the extraction of aluminium. The answer is carbon. Pretty obvious answer. Write the equation for the reaction that occurs at the cathode during the extraction of aluminium by electrolysis. So at cathode, if you remember, you get aluminium. Okay, pure aluminium gets collected at cathode. So what will the equation be? It would be Al3 plus 3 electrons will give you aluminium. Next is give the equation for the reaction which occurs at anode. So at anode it would be losing electrons. So Al minus 3 electrons will give me Al3 plus. Now next, name the following. A metal which is liquid at room temperature is mercury. Even a 6th grader would know that. A compound which is added to lower the fusion temperature of electrolytic bath in the extraction of aluminium, that is cryolite and fluorspar. So you need to remember both of that, cryolite and fluorspar. Now the next one is not in the syllabus. 7th, write balanced chemical equation for the reaction of aluminium oxide with sodium hydroxide solution. So aluminium oxide Al2O3 plus sodium hydroxide NaOH will give me NaAlO2 plus water. Okay, I am not balancing the equations. Please try to balance the equations on your own, and if you're not able to, let me know in the comments section below. Now let's move on to question number 8. Write balanced chemical equation for the following reactions. So first one is not in the syllabus. The second is calcium bicarbonate and dilute sulfuric acid. So calcium bicarbonate is what? It is Ca HCO3 whole twice plus HCl, which will give me CaCl2 plus water plus carbon dioxide. Now next is the amount of carbon in cast iron more than or less than or same as the amount of carbon in steel? So it is more. And how do we know that? We know that from the same chart that is mentioned in the book at the end of the chapter. Now, name an allotrope of non-metal that allows electricity to pass through it. So the answer is graphite. Okay, we also did graphite is an allotrope of carbon in probably organic chemistry. If I'm not sure if you have read that. So make sure that you go ahead and check that out. If you still have doubts, I would be happy to help. Alright students, let's move on to question number 9. So the 9th question says A to F below related to the source and extraction of either zinc or aluminium. So zinc is not in the syllabus, so we won't be working on that part of the question. So for aluminium, if you think bauxite, yes, we use bauxite. Coke, no. Cryolite, yes. D is a froth flotation, no. Sodium hydroxide solution, yes, that is the first step, so that is yes. Zinc blend, no. Write down the 3 letters each from the above list which are relevant to zinc, so we are not doing that. Aluminium is ACE. Okay, let's move on to the next part. Fill in the blanks using the most appropriate words from A to F. So the same words that we had A to F, we'll be using that. The ore from which aluminium is extracted must first be treated with sodium hydroxide solution. So sodium hydroxide, so that pure aluminium oxide can be obtained. Pure aluminium oxide is dissolved in cryolite to make a conducting solution. Then write the formula of cryolite, that is Na3Al(F6). So Na3Al(F6). Let me write it clearly for you guys. So Na3Al(F6). In the manufacture of iron, a mixture of limestone, coke and iron ore is, okay, that is not in the syllabus. Calcium, copper, lead, aluminium, zinc, chromium, magnesium and iron. Choose the major metals from the list given above to make the following alloys. So stainless steel will be formed from iron and chromium. Iron and chromium, and brass is made from copper and zinc. Next question is question number 12. So question number 12, we have Bayer's process, that is in the syllabus. Hall's process is there, cryolite is there. Then roasting, calcination and concentration is not. So now let's look at it. So Bayer's process is the first step. So sodium hydroxide. So I'll just mark it. So sodium hydroxide. Then Hall's process would be sodium carbonate, and cryolite will be solvent of alumina. Now next is question number 13, galvanization. So now this is again from the properties of your alloys, that is the last page of the chapter. So galvanization is taking place with zinc, so let me mark that. Then bodies of aircrafts, so they are made from duralinium, so that is this one, duralium. Then surgical instrument is stainless steel. Fourth is expands on cooling, that is metals. Then statues are made from brass. Now moving on to question number 14. Each question has 4 options, out of which only one option is correct. Mark the correct option. So let's look at the first question. Which of the following pair of metals are extracted electrolytically? So this is not in the syllabus. Metals which react reversibly with steam is not in the syllabus. The chemical compound present in zinc blend, So zinc blend is this zinc sulfide. Then solvent used during electrolytic reduction of pure alumina. So that is cryolite. Okay. So solid cryolite, no. We'll be using molten cryolite because you need it as a in the solution. Electricity has to pass through it. So electricity cannot pass through a solid form. Two metals which react with acids and alkalis to liberate hydrogen. Okay. So the answer would be lead and copper, sodium and copper, lead and silver. The answer would be D, aluminium and zinc. Okay, aluminium and zinc. So, my wonderful, wonderful students, thank you so much for such an amazing response on the channel. This is it for today's session. We have successfully covered all important board questions for metallurgy. I understand a lot of students find metallurgy really difficult. So if you want to practice more questions, let me know in the comment section and I can make a video of more questions on metallurgy. So, in the meantime, please make sure that you subscribe to the channel and share it with your friends and family. We'll catch up in the next session, that is hydrogen fluoride. Thank you. I hope you have a beautiful day.